Hello everyone. So we have brought you our second video. Have you ever wondered how we can implement a stack using only queues? In this video, we'll break it down step by step and write a code implementation. So let's get started. Hello everyone. So we have brought you our second video. Here's what we'll be covering today. First, we'll start by understanding what stacks and queues are, their fundamental concepts, their basic operations with real-world examples. Next, we'll learn how to implement a stack using a queue, a common interview question and an essential concept in computer science. Then, we'll move on to a hands-on code demonstration where I'll show you step by step how to implement this using Java. Finally, we'll analyze the time complexity of our implementation, discussing the efficiency of each operation. So make sure to watch the video until the end. Before we dive into the implementation, let's quickly recap what stacks and queues are. A stack. A stack follows the last in, first out principle, meaning the last element added is the first to be removed. Think of it as a stack of plates. Then a queue. Queue follows the first in, first out principle, where the first element added is the first to be removed. The operations in a stack are as follows. Push. This operation is used to insert an element, pop. This is used to remove the topmost element in a stack, top. To get the top element in a stack is empty. This operation is used to find if the stack is empty or not. Main operations in a queue. Enqueue. Enqueue is used to insert an element to a queue. Dequeue. This operation is used to remove the front element of a queue. Front. This is used to get the front element of the queue. Alright, let's take a look at how we can implement a stack using two queues. On the left, I have a stack data structure which allows me to see all the operations I am performing. Now I want to achieve the same behavior by using a queue. Since a queue follows a first in, first out approach and a stack follows a last in, first out approach, we need to come up with a way to modify the queue's behavior to match the stack. To demonstrate this, let's push some elements to both the stack and the queues. Now, notice that in a stack, the elements are stored in a top-down order, meaning the last pushed element, 45, is at the top, followed by 23, 67, 54 and 10 at the bottom. But when we add these same elements to the queue, they are stored in a linear order as 10, 54, 67, 23 and finally 45. The first element entered is at the front and the last element entered is at the back. So, here's the challenge. When I call pop on my stack, I expect to get 45 because it's the last element that has been entered to the stack. But if I call pop in my queue, I get number 10, the first element that I pushed. This is the fundamental difference between stacks and queues, and this is exactly what we are going to fix. So we are going to get the operation like in the stack to queue. Now, how do we make a queue behave like a stack? This is where the auxiliary queue comes into play. The idea is simple. Whenever we call pop, we need to somehow reach the last element that was inserted just like in a stack. To do that, we are going to follow some simple steps. Likewise, first we are going to transfer all the elements other than the last element to this auxiliary queue. Then we are going to remove the last element from the first queue or Q1. Then we are going to swap the queues so that the other elements are in Q1. So let's see that in a demonstration. Now, if I call pop, I'm going to move these elements except the last element 45. So I'm going to move these from Q1 to Q2. Right. So now you can see we can easily pop out this 45 as our first element. So basically it's going to act as a stack because the last in first out principle will be applied here because 45 is the last element we have added to this queue. So we'll pop this, it will be removed, and we are going to swap these queues. So you can see Q1 contains the remaining elements and Q2 is the auxiliary queue or the queue we are going to move when we are popping elements. So if we pop another element, we are going to move these elements, the first three except the last element, and then we are going to pop the last element or 23. And there you have it. We have successfully mimicked the stack behavior using two queues by cleverly rearranging elements during the pop operation. This method ensures that the last inserted element is always the one removed first, just like in a real stack. Okay, let's get started with the code implementation of creating a stack using queues. First, we'll initialize the data structures. Queue, which is going to be integers, the data type. Let's name it Q1. In Java, we are using linked list constructor to create queues. Then next we need to initialize the auxiliary queue, which is integer. Let's name it Q2 and new linked list. Okay, we are done with initializing the data structures. So let's get started with the basic operations such as push and pop. We are going to mainly focus on that too. Simply, the push operation will be as follows. We are passing in data q1.add. This is the operation we are going to use, and we are going to pass the data as the parameter, and we are going to increase the size by 1. So we need to first initialize the size variable. Okay, so the push operation goes like that. Just normally we are going to add the data which has been passed as a parameter to the queue Q1. So the next part is pop, which is a bit complex. We need to throw an exception if there was to handle exceptions. Yeah, it should be capital exception. Yeah. So if the queue is empty, we are going to throw an exception there. Is empty it's also a operation. Throw new exception. We are going to print this message: the stack is, or in fact the queue is empty. Okay, so let's continue to create this method, pop method. Yeah, first we need to move the elements, the items in Q1 to Q2, but except the last element. You can remember in the demonstration, except the last element, we are going to move the other elements to Q2. So it's done using a while loop. While we are going to add the elements to Q1. We are going to remove it from Q2 and add it to Q2. Yeah, we are going to remove it from Q1 and add it to Q2. That will be done here. Then we are going to store the removed element in a variable like this: removed element, the one that is removed. Yeah, and we are going to decrease the size, so it's technically popping or removing the item from the queue. Then we are going to do a special thing. If you can remember in the demonstration, we are going to swap the Q1 and Q2. For this we need a temporary queue. We are going to name it as temp, it is integer temp. Yeah, and we are going to equal it to Q1, and Q1 will equal to Q2, then Q2 will be equal to temporary queue. Yeah, that's basically how we swap the queues. We need to return the removed element. Yeah, we are going to return it, and we are going to show it in the main function. Yeah, there you go. So we have created the push operation. It's simple, just we need to add the elements to Q1, and in the pop operation we are going to move the elements other than the last element. We are going to move them to Q2, then we are going to remove the element, the last element, and we are going to swap Q1 and Q2 using a temporary queue. So let's see if this have worked. So in our main method we are going to create a queue. So we are going to make an object. Let's name it SQ. It's going to equal new stack using queue. Yeah, we created the object, and we are going to simply push some data to this stack. Okay, now we have pushed some elements, some items to this queue. Actually it's a queue, but now it's going to work as a stack. Now you know, in a stack it follows last in first out principle. So the last element we have push is 45. So if our code implementation is correct, if we pop an element we need to get 45. So let's see if it's going to work. Yeah, we are going to, let's say, the removed element. we are going to pop one time. Yeah, actually we need to throw some exception here. So let's run this and see if our code has worked correctly. Yeah, you can see we are getting 45. So what do you think if we pop another element? We should get what? Now this is gone. 45 we have already popped. We need to get 23. So let's see if we are getting 23 by popping again. Skew.pop. And see we have got 23. So now basically we have created the stack using queues. Let's analyze the time complexity push operation. This takes big O of 1 time because we simply add the element to Q1. In the pop operation, this takes big O of n times since we need to transfer n-1 elements to Q2 before removing the last one. So if you found this helpful, make sure to like, subscribe and drop a comment below.